Welcome everyone back to my second tutorial series of image stitching. So in this tutorial we'll finish our first part where we started image stitching. So in last tutorial we defined 6 steps we should do to finish our image stitching, and we there finished 3 of these steps, so 3 more steps left. So 3 of them are to run RANSAC to estimate homography, warp and align stitching, and finally stitch the images together. So let's move on this, and I'm not going to waste time talking. I'm just want to do stuff to make this video as short as possible. So once we have obtained best matches between the images, our next step is to calculate a homography matrix. So as we described before, the homography matrix will be used with best matching points. So to estimate a relative orientation transformation within 2 images. So let's begin, but before moving on this, I should mention that we have to swap the left and right images because, well, there is a reason, and maybe I'll show you later if I won't forget that. But now let's just do this. Okay, so here we don't need image showing something to us, and let's begin with creating a simple function. So here I'll define a minimum match count variable, match count equal to, for example, 10, and here I'll create an if function. So if our length of these good matches are okay, we do something here, and in other way we use else. So here we only do image stitching if our good matches exceeds our required matches. So otherwise we'll simply show a message saying not enough matches are present. So let's write a simple message function. Not enough matches are found, and here we just write some division, and here I'll add length of good divided by min match count. Where is my minimal match count? Here it is. And yeah, it should be like that. And now we will write all the code here. So this part of code is quite complicated to explain, but you'll see. So in this statement we'll convert our key points from list of matches to an arguments which will be used for find homography function. Well, I can't explain this in details because I didn't have time to chatter this, and well, anyway, there is no big use to chatter this. Anyway, let's write function. So this will be key points 1, and we use something like this, query idx query. I wrote something wrong. Query. Then we write pt for in good. Well, we could write this function in a few lines of code, but well, let's keep it as it is. And this will be reshaped to -1 1 and 2. So we copy this to this line of code, and dst keypoint, there was something wrong. I key m wrote, so keypoint, and here will be train idx, and everything the same as it is. So here right now we have arguments we need for homography function. So here we write m mask equal to cv2 and find homography. I missed one letter. Okay, find homography, and here we just copy this one, dst, let's copy it also, and here I'll run a cv2 RANSAC function. Well, I'll add everything to my website tutorial, so with links where you can read more, so keep reading there. And right now we already have almost an image, so let's right now finish with it. So I'll show you a overlapping region right now. So we write hway img1.shape, then we write opts, for example, and numpy float 32, and then we go with something like this. Well, this might be a little complicated. It's even for me quite complicated, so I just recommend you copy this from me and play by yourself with all these parameters. h-1, and then we add one more, a w-1 and h-1, and one more left, so it is w-1 and 0. So here we just do our reshape. -1, 1 and 2. So right now we can do a perspective transformation. So we write dst cv2 dot perspective transformation, just like that. Oh, sorry, transform. It is perspective transform, and just write pts m, and right now we just can show our image, to try at least show if everything works fine. Image show, and here we can copy this line. It will be much easier. Or original image overlapping, we can write overlapping, and here we just write, let me think, oh, I forgot one line. So after dst there should be one more, so img2 equal to cv2 dot polylines, and here img2 numpy integer 32, write dst, and then we leave our array, write 255 color, 3 and CV2 line AA. So yeah, and that's right. Okay, let's save it and let's see if I didn't wrote any errors. Reshape it. I wrote shaped. Okay, reshape. DST name. Well, oh, here I made a small mistake. So here we have our overlapping region. I think it's here on the right side. I think it's on the and as you can see, if I'll write like that, it will change its side to another one. So right now overlapping region is this one. So but we need to save it as before, like that. And let's, I think, move forward. So right now we received our overlapping region. So once we have established our homography, we need to warp perspective. So essentially we need to change the field of view. In this way we apply a following homography function, which I'll write right now. After we leave this function, well, okay, I'll write a function to warp perspective. I think it's warping, if I didn't forget anything. So warp perspective, and here we'll write img, and here I'll write img shape. Sorry, it's the wrong button. img shape 1. So we increase the size of our image. img shape 2 of second image, and after this we write on img shape 0. Yeah, like that. And well, we could show it right now for us, but that's not the end. So we finish on this. So DST from 0 to image shape 0, and again from 0 to image shape 1, and we make this equal to our image. So here we have our right side of image, which is overlapping. So to this we need to add a left side of image. So we are actually summing the images here, and after this, in this moment, we should have already a stitched image. So let me show you this for you. We'll call this stitched image, and here just DST, like that. And anyway, right now I just wanted to show this overlapping region for you. So in this place we don't need this anymore, I think. Well, this we don't need, because yeah, I think we don't need this. But I'll show you how my stitched image will look. So let's build it and let's see. So as you can see, we have our images, at least with the dark side of right in the right side. So, but anyway, it was stitched. It is working, and no matter what you'll say, you can compare this image with your original image, but well, I don't think that you'll find differences. So anyway, right now what is left is to remove this dark side of image. So here once more we'll write one more function define. So we define a trim we'll call frame function. It will be quite easy. So here we, for example, crop top, and if not numpy sum, here is frame 0, and there we return trim frame from 1 to the end. So this way we'll check if our top has fully black pixels. So the sum should be 0 here, and if it is 0, it is black. Otherwise it is not black. So this same way we'll do for top, left side and right side. Well, we should make it only for right side, but who knows, maybe we'll need another sides also later, or you will need, not I, so it doesn't matter. So I'll just write a function for this and you can use it later. So just like this, and here will be just like this. Oh, sorry, I almost forgot something. Like this, and here is -2, and here will be dot 1, and yeah, I hope I wrote it fine, but we'll see. And final step is, let's see what we have here. So we call our trim.st. We'll add one more line, is here crop, and if you would like you can not show this image but save image, save like that. Okay, I'll save it, and oh, something wrong is here. Numpy, oh, I forgot not. Okay, just like that. Let's save this, and well, too many indexes for array. Okay, as I thought, I made something wrong. -2. Well, actually it is something wrong here. Oh, I don't need this. I think, well, let's save this again. Again something wrong. Oh, okay. Return frame. Oh, so everything is fine here. So we have a cropped image in this final image. So as you can see, it's quite simple. I'll post this code to my, of course, tutorial, and you can use it by yourself. You can use my image, you can use your own image, it doesn't matter. And yeah, in this tutorial post we learn how to perform an image stitched and panorama construction using OpenCV and wrote a final code for image stitching. So our image stitching algorithm requires 4 main steps: detecting key points and extracting local invariant descriptors, get matching descriptors between images, apply RANSAC to estimate the homography of matrix, and apply a warping transformation using homography matrix. So simply 4 steps and you have stitched image. So, well, this algorithm works well in practice when constructing panoramas only for 2 images, and if you want to do it with more images, you should change this code, but yeah, shouldn't be so hard for you if you understand how everything works. And I hope you enjoyed these 2 tutorials, which was now and which was before. And this is not the end, I should say. I'll continue on this stitching, but well, we'll see on the next tutorial. So thank you all for watching, good luck, and see you next time. If you liked, subscribe and like, and goodbye. Thank you all for watching.